Yes, isn't that lovely? I picked up on that little melody last, was it, week ago, 2 weeks ago, when I was with Chief Crow. And he played one of the little things he played in the background was a loop of that. And I picked up that melody. I'm like, oh, I haven't heard that in like 25 years. It got stuck in my head. Sorry about that.
Nice. Baldini, I really enjoyed that. Obviously, I was the one conducting all of that.
Yes, I like it. When you're a superconductor.
We should talk about that. We should talk about quantum locking. We should talk about quantum locking and how that could be how UFOs work. But first, I'm going to start the show by welcoming everybody who is here. Good evening, everyone. I have the great Baldini, and I have Cami Nodell, and I have Bob Nodell. Welcome, everybody.
Well, thank you. Thank you very much.
The first winner of the Nodell Prize, as a matter of fact.
That's right. First recipient ever.
Yes, the Nodell Prize. That is the highest prize that I could ever conceive of. Maybe one day, and this is why we're doing this stream, is because I have a dream that one day I want that award.
The dream
right
stream.
Now I'm not qualified whatsoever. I'm the least qualified person for the award, but I want to show people that anything is possible if you have the desire to learn. And one of the things that I wanted to ask Carissa that I didn't get a chance to in my debate that I did on Modern Day Debate the other night was, I mean, I'm always willing to reserve the right to be wrong, to make mistakes. But I was so curious to know if she is also willing to be wrong, and if maybe if she is presented with adequate information that she would accept it, because I like to go at it this way. I want to take personal accountability that I failed to demonstrate properly how obvious it is that we are talking about a significant event here. And it's so obvious to me that I think that I was a little bit lazy in my explanations. Like, oh, maybe I don't really need to explain Bell's theorem, or maybe I don't really, like, oh my gosh, I can't believe I didn't point out this fact. One of the things that she did, other than try to explain gravity and tell me that she told me that the footage, that she didn't trust the footage. Well, hello, the freaking experiment was live streamed. So she's the conspiracy theorist. If she thinks that we're in cahoots with YouTube, that Zach from Good Times for All can like doctor footage live, right?
Yeah. Well, she pretty much already gave herself away on that, Rose, because I think you read it right out of Wikipedia saying where it says that gravity is not a force, right? Because according to the mainstream interpretation these days, gravity is a bendy space-time, right?
The effect of the result of the unequal distribution of mass that through bendy, timey-wimey space-time.
Right. But she's like, no, it's wrong. It's wrong. And I'm like, whoa, man. Holy cow.
Yeah, if you're going to claim that to be your end-all be-all, if they're going to worship the Wikipedia, they can't just pick and choose and say, here's a little bottle of whiteout, the gospel according to, whoever. But yeah, I see this over and over. It's not uncommon. As you know, we had a similar conversation with your friend, the wino, Rose, who again comes from a position of the Dunning-Kruger effect, right, where they have every belief that they're not only right but they're intelligent, and this comes from the indoctrination centers, right? I often say that the higher the education, the greater the indoctrination, or the higher the education, the deeper the indoctrination, because what they really teach is a skill set of learning how to position yourself as knowing something by repeating somebody else, and if you can repeat that well, you get the gold star. Yeah. And that's really it. And so if you ask a question, even if it's a very prescient or salient question, you're dumb, right? If you don't repeat it exactly the same way. In fact, if you can do a better job at repeating it back, you're dumb, because that's not what you're supposed to do. You're supposed to repeat it back exactly the same. And so it just reinforces a belief system that they have, that if they can repeat it sort of, then they get the gold star. And this is true in every aspect of life. If you go out right now, people think they got the gold star because they sort of heard what Fauci's said.
Yeah. Hey, Rose, somebody in the chat is saying that the sound is low. I don't know if you can crank it up any or not, but
I think it's Rose's mic seems a little low.
I will fix it.
Okay.
I always forget to open up the software that goes with my mic, so it'll just take a second.
Okay. No worries.
Thanks, Bob.
No worries. But
How's that?
oh,
Better.
yeah, well,
Much
that's a
better.
lot louder
Much-
here.
Yeah, maybe I should like turn on the software for
Yeah.
the hardware.
It always helps
Yeah.
me. It always helps me. That's a good place to start.
Yeah.
So anyway, I think again, it's not uncommon with any topic that you come to, especially if people, as we see in the chat, I think most people here get it. We're preaching to the choir, right? That people don't want to look dumb. They feel if they indicate that they have made a mistake, right? That was one of the things that for me that I was so irritated when I first came to grips with the idea that the world wasn't what we've been taught, because it's so easy to see. It's so right there in your face, and all you got to do is really question it. And I hadn't done that for almost half a freaking century. Get the fuck out of here, man. I think that like I know something, and then that's in your face. Like, oh, come on. It takes a certain, I think, just a commitment to the idea of truth. That there is an objective truth and that you can go look for it. If you can't accept that, then I think that somebody's going to have a problem.
And the amazing part is the mainstream ball earth promoters are 180 degrees out from that. They have to get used to creating and telling lies. And I'm not saying that idly. I mean, we all know that they do it, but I mean, I don't know if you guys watched Taboo Conspiracy's latest video that he just released about, I don't know, an hour ago or something like that. But I was blown away. I couldn't believe it. So somehow, apparently, one of the letters that was written to Ben, it turns out that Wolfie told his brother to write that letter, right? And then he brings Simon Dan on, who then admits to writing Ben all these letters, saying, well, I hope he learns a lesson from this, straight up point blank admitting that he's trying to mislead, by deception. And then it turns out that Bob the Science Guy has also written another one of those letters. So, I mean, these guys are doing this on purpose, like they're doing it for the good of us, which is just incredible.
I just want to show you the error of your ways. I'm such a great person. I just want to show you where you're wrong. I'm here to help.
What this falls under is the tag of social media influencer, and it really is a job out there. We do shows and we act like children in the name calling and that, but in business and in the industry world, what they do is they pay people to go and influence you on social media by making fun of you, by, again, trying to taint the chat and taint people's opinion around it and get into the chat rooms. And they do it on a political basis. They do it on a religious basis. They do it on all sorts of corporate type of industry basis. But it's called, again, influencing on it. And just the number of comments that I even got on my little bitty channel, because I stay in the background, but my little bitty channel had more comments than views. And the comments were all vulgar. They were insults. They weren't. Nobody took on Faraday effect. Nobody took on any of the science or the issues on it. Nobody took on, and they never will. But they did call names, and then say that you're taking away my freedom because I won't let me name call. I won't let you. You won't let me be a child on your channel. How dare you?
Yeah, it's so ridiculous. Oh my goodness. Yeah, I just, today what I want to talk about is I want to get to the bottom and fully comprehend why it is that light is not a particle but a wave through understanding Bell's theorem. And the way I understand it so far, and I just want to practice saying what I think I understand so far, and then you can help expand on it. But with the Faraday effect, when you're crossing the two polarized filter, it's like going from blinds to a wicker chair, so everything gets blocked out. But then the paradox is that when you introduce a new filter, that now all of a sudden light can come through. And if I recall correctly, the what you were describing, I didn't understand what you were saying completely, but you mentioned the ebb and flow of the wave making that possible. The fact that the light is in a wave, and so maybe it's like coming out the top and the bottom and going. I don't know. I shouldn't have said that, but go ahead, Cami. How much of that did I get right?
You got a lot of it right on here. What I mean is that light is a wave, and with waves you have cancellations. So it cancellations.
Actually, light is waving.
Light is waving.
Let's
You're
make that
right.
a little clearer.
Oh, let's make that very, very clear, because you just caught me saying that entirely wrong.
Yeah.
Light is not a wave. Light is not a particle. Light is a perturbation in a wave that we recognize as light. So as the wave is excited,
well
we
done.
perceive it
what
as
abation?
light.
A perturbation. To
a
get
perturbation.
perturbed. To get perturbed. To get unsettled.
Okay.
Emotional.
Unsettled.
Yeah.
And depending on the harmonics and the resonance of the perturbations, we interpret it as light, and we interpret it as the entire spectrum, actually. You have your longitudinal waves and your transverse waves. Your longitudinal or like percussion waves, and your transverse are again more three-dimensional, where if you took your walls off, so in other words, like a percussion wave, you need the air and the atmosphere around you to be percussed, and you feel it as a percussion wave. Can we explain this better, Baldini? Bob?
Yeah, there's it's a compression wave, essentially that you're compressing the atoms, if you want to think of, they call it molecules. We'll just go with that for terminology, whatever is there, whatever the media is. But in order to have a wave, and I'm sharing the screen now, in order to have a wave, there must be so wave is energy. Right? Think of wave as energy, and the energy is moving through some media, whether that's water or air or whatever. But you must have a media for that energy to move through. And then the wave is represented here, a transverse wave that goes, you can see it kind of go up and down here. And so what you see there is representative. And then when you combine them, or you get wave interference, right? So if I come here and you do this, and you can see wave interference, then what you see,
I know that video.
Yeah, right. Exactly. Right. So the waves interfere with one another. And as they do that, it causes additive and subtractive waveform. Right. So when you get here, when you put two in the same phase, they add to one another on top of each other. If you put them out of phase, or take B and make it exactly the opposite, the result of A plus B will be nil. There's nothing there, and they cancel one another out, and that creates a node or a void area. Typically, it's neither one or the other, and this is true with any type of wave, whether that's an acoustic wave that is a longitudinal compression wave, or whether it's a transverse wave like this would be sine wave, sinusoidal wave. It doesn't matter. They're all going to kind of operate in the same, which is a perturbance within a media of energy. The energy creates a perturbance, and that is so we just take its frequency, how often it happens, its amplitude, we measure those, and that's what the wave is. Those are the characteristics of a wave, is how far apart they happen, that's its frequency, how much energy is being brought out, that's its amplitude, and those are the primary characteristics of the wave over time. And so it's not that difficult. What is remarkable is that it's very clear to see, when you understand wave dynamics and how that occurs, that you could look at light and see this polarized light occur in exactly this way, and then say, well, it's not that.
I know.
Yeah.
So we could think about light as visible energy. It's just, there's waves everywhere all the time because of electromagnetic fields, but the light is the same thing, but we can just see it. Is that correct?
Absolutely.
Yes.
Perfect.
So what does it look like if you were to do a diagram of what's happening when you introduce that third polarized filter? What is happening to those waves that allows us to suddenly be able to see it again?
I'm glad you asked.
Okay, do you want to take up Baldini? Do it.
I'm going to start with phase one. To coin a phrase, phase one. All right. So when you get the third one in, right, then what happens is it can either be more or less. Right. So here you can see from what's happening here with the green and the blue, it turns into the red. Well, you add a third one in there, right, and then it's going to be even bigger yet still. Right. So when you introduce a third one in there, and it becomes even greater still.
So they're augmenting each other.
Correct. Well, it depends. Yes, it's contingent on their phase to one another. That is
Your resonance.
Yeah, whatever the resonant frequency is. So if they do hit at exactly the right phase to amplify one another, they will. And if they hit at a place where they're going to subtract, they will. And each place that they tangentially cross, then they're going to either amplify or subtract, depending on the angle at which that occurs. And so this is what you see here. Right? This is pretty basic, but whenever you get that third filter in light, right, it works the same way. It's adding a third angle, right? So now you're getting a third angle of incidence. So you've heard the expression: the angle of incidence is the same as angle of reflection or refraction. The same thing.
Or critical angle.
Right, exactly. The same thing is in place here, happening in this situation.
What makes something a critical angle? Like adding the word critical to angle. What did you just do, Cami?
Okay, I'm going to read this from something that I'm going to wind up putting on your screen. Do you want to bring up in the StreamYard chat? I brought up an article called Gemstone Optics.
Awesome.
And I want you to. What this is this is an industry. This is when you take things out of theoretical and put them into industry where you have to sign legal documents based on it. So I want you to look at how they teach people that have to teach. And I noticed that this seems to go through medicine and through a lot of fields. I can only play with my industry, but I did look through different things, and what I'm finding is that even though it says it's gemstones, if you go through here, it says a gemstone's optical properties. We could take this into anything's optical properties are very sensitive to minute changes in composition and strain within their crystal structure. Therefore, accurately measuring them is very useful for identifying and distinguishing one solid or one matter from another. This article will cover the basic terminology and concepts of gemstone optics. If we slide down and go into critical angle, your question is going to be critical angle. What is that? Light traveling from a given medium to a less dense medium, for example, from a crystal into air, may strike an interface at such an angle that at the interface, the light is totally reflects back into the denser medium. The incidence angle at which this takes place is known as the critical angle. This angle has great significance for gem cutting. If a faceter cuts a gemstone at angles matched incorrectly to its refractive index, light entering the stone may leak out the bottom. This causes a loss of brilliance.
And
however,
what you can do too, just to quickly interrupt, is that you can a great gemologist can actually take the wave of light and bounce it back and forth between the two planes, right? So that it bounces back and forth between the two surfaces. So you have one surface, let's say, parallel to another at a specific distance, and you can change the angle of light just so that it bounces back and forth between those two, and then comes out in a greatly amplified amplitude at the end.
You can do exactly that. Not only can you, but they do that, and we'll take it really good because a gemologist is not actually cutting the stone and making this happen. What a good gemologist can do is she can look at a stone, especially if something that he or she is very familiar with, like a diamond, because this is a skill I have. I've been tested on it. And you can look by looking at a round cut diamond on its high and low spots and exactly where they hit. And you can tell the exact dimensions, proportion. It would be the same as measuring the diamond out, saying that the crown angle is 34.5 degrees. The pavilion angle is 40 3/4 degrees. You can actually look at it face up in the table position and see by how it's treating the light in that material and back out the math on it. That's how we look at diamonds and mountings and tell you how much they weigh. You wonder when you have something appraised and they're like, why are they putting a weight on a stone? They're not taking it out and putting it on the scale. It's because a diamond has a specific gravity. We can look at the angles that it's bouncing on, and we can come within a very, very high tolerance of accuracy by using this information. And you'll notice they'll put polarized light in all of this. What I do want you to do, though, is go back to your basic...
you just reminded me of Brewster's angle, because I wanted to mention that you taught me
that's the critical angle, yes.
Okay, so that is the critical angle that is unique to the medium.
Yeah.
So,
yes, exactly. Ding, 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 ding.
Winner, chicken dinner. Yep.
No,
I'm so proud of I didn't even know I was about to impress you, Baldini. I'm just going to
love
quit
you
while
too.
I'm ahead. Go ahead.
I love these moments. It's like nothing
Oh,
makes me
Rose.
happier. Nothing makes me happier than seeing the light bulb going on over the head. It's like, oh God, I've lived for those moments. Yes.
Now I'm going to take this and I'm going to drop it back to you guys, but I'm going to take in here again. This is a article on the screen that Rose, I'm scrolling and you're not. I want you to see that it's by Joel E. Aram, PhD, FGA, and it will give his credentials as very highly credentialed. And this is
which part?
look, okay, at the very top of the article, it will say by Joel E. Aram, PhD, FGA. This is who writes it, right? And this is an industry. It's telling you what the physical and optical properties of gemstones. And this is, again, something you use on legal documents and identification and money. If you go down to where it says wavelengths of light, they don't discuss particles or anything like that. They flat out tell you, because the way you're going to have to do the science is light travels in the form of waves, like ripples on a pond. They don't say it changes over to particles, because you know what?
It doesn't ever.
You can't do the math otherwise. You cannot doing it. Now you're adding that third Polaroid filter in that we were talking about. Where we did it, that was something else that occurred to me, that when they say, when you're looking up in the sky, why isn't everybody else picking this up? I want you to know one of the few sciences I haven't seen polarized filters used in is astronomy. And they might say, well, it would take away half of the light. Why would you do that? But it would also change the entire way that you look at light. Just like in diamonds are graded by northern daylight only, the Kelvin spectrum. You get a lot of information. The color changes if you change the angle of light you grade from. If you look at things differently, you see more, you can isolate them. I imagine that they're telling people that if you look with the Polaroid filter, don't use it on a telescope, because it would probably cut out half of the light, but it would do a lot. So I imagine that there's not a lot of people looking up at the sky with Polaroid filters on. If we really wanted to look for some of these phenomena, though, what occurred to me is we'd look up at the sky in a way that we probably haven't done it before since Alberuni's time, and that would be looking up at the sky through cross Polaroid filters. Because if you looked up through cross Polaroid filters, something else might, hitting an angle that would let light in, would show another polarized source.
Yes, another source. And then, so Rose, you remember the Michelson-Morley experiment?
Right. That's the experiment that proved that we're on a stationary plane and that there's ether.
Interferometer. That's right. And so the basics of the interferometer, as I have on the screen here, is that essentially you shine a light, laser, right through a screen that breaks it up. Right, and then you recombine it, and it's the fringe, how it recombines, that shows that. Well, here's the thing: is like, how can you have this? Is kind of goes back to their to their nonsense there. Well, then how can you have it be a particle if what you're doing is everything about it is wave theory, which is an interferometer, right? So that entire experiment is completely based on
it being a wave.
It being a wave.
And there's
Hubble's law.
And there's a whole other point to this as well.
Huge one.
In addition to that, you also have to take into consideration the speed of light, right? Supposedly, right? Now, and I've mentioned this several times on GLOBEBUSTERS, if you shine a light and it goes through, air, it's supposedly traveling at 186,282 miles per second. But then when it goes through water, like if you point that beam at a fish tank, it slows down to about 0.6 C, or 60% the speed of the light. But then when it comes back out, then all of a sudden it's back to 186,202. Now, that cannot happen if it is a particle. And
where does it get the energy? Yeah,
that's right.
Yeah,
to accelerate or not.
That's right. Exactly. So what's happening is this is where when we talk about the rate of induction into the ether, that this makes perfect sense, because simply you've changed the medium, therefore the rate of induction, changes, commensurate with the medium. So, I mean, light being a particle is just horse manure.
And him saying it's induction again shows that that this is a wave, just like a electromagnetic wave. If you say it's a particle, imagine something with any mass whatsoever hitting at that speed. It would blow you apart. It would hit your eyeball.
Baldini, you were able to show a visual representation of how light is operating as a wave. What are they saying it looks like when they try to describe the behavior of light in regards to being a particle?
They will always say that it acts like a wave until they get into quantum physics, and then they say, but it behaves like a particle.
But what would that look like? They are not showing us stuff because it's quantum, so that's how they get away with it?
Well, little particles, little bouncing balls.
It's too small.
Yeah.
Right.
The best diagram to show that, Rose, came from a movie called What the Bleep Do We Know? And it's a little cartoon piece by this little guy named Dr. Quantum. And they show essentially how that works, the double slit experiment. But, it's just nonsense what they're actually doing there. But I mean, that is a good demonstration, at least, of what they're trying to say.
Yeah, and what I wanted to share with you, Rose, is this, right? Don't conflate your ability to either convince somebody or their ability to understand something with your ability to explain it or understand it. So in other words,
I want to conflate, Baldini. I want to just improve my abilities to make up for their lack thereof. And I think that is a statement of someone's ability to be a teacher.
No, but you can't always do that, right? And they have to want to. They have to want to, right? So when the student is ready, the teacher will appear, and they have to want to know that information. Otherwise, you're coming from a position of saying you're wrong, and therefore you're dumb, and I'm going to fix you because I'm the smart one, and that's going to create an immediate posture of defensiveness, and then they're not, then we all know what happens thereafter. The forehead veins start to throb, and it's cognitive dissonance all day long. So it's an infuriating, frustrating, exasperating situation. Again, I think the best you can do is have your ducks in a row where, just like this, you know that right? You understand the material, and then it's not contingent on whether they're able to either receive that information or understand it. And so I'll often tell people, right, I can explain it to you, but I can't understand it for you. I can't get that far. So
Yeah, I think it's really difficult in these situations. Like, my heart goes out to the opponent because I suck at debating, because what I'm saying makes sense to me and I just feel like it speaks for myself. And if someone's not able to comprehend it, then I just think that's self-evident to anyone who is capable of thinking, who's observing. So I feel like because of this tribal thing that we can't, it seems like we'll never get rid of this whole tribal idea where there's like a winner and a loser, and there's the globe side and the astronomy education side, and then there's the, critical thinking deprogrammed, try and be interested in discovering the true nature of reality and being okay with making mistakes. Like, it's just two different worlds. And so it's almost like she was sacrificing herself, because by putting herself into that situation, she's removing her ability to be open-minded, because she feels like that's the nature of a debate. She has to take that stance. So it's almost like at that point, knowing that I'm really just trying to reach out to the audience for the people that don't have any, like, they don't have to worry about being embarrassed. Like, everything's just going on within the confines of their mind. But then after the fact, I'm like, oh, I want to contact her and find out, like, maybe there's something that we both agree on, that we can relate to, that we can talk about separate from all this, and, cultivate a relationship or a friendship where then off the air, I could just kind of try to
there was a time,
find out what's really on her mind.
There was a time when that might have been possible. The more and more what seems to have happened is the biggest play that I've seen come out in the last 2 years is even less the foul cheese and the beer bug, is this polarization has become so amplified that everyone now takes a position that if you disagree on any aspect of any conversation, that somehow the other person is the enemy, and they will immediately break out these, trigger words. And of course, trigger words they're there for a reason. it's a trigger. Right?
Yeah, that's even happening on the flat Earth side. I mean, look at the flack I take for the downward acceleration vector, and even this topic from other flat earthers about this so-called second sun. It's unbelievable.
Absolutely, and it has very little to do even with the content itself, and it has to do with this idea that somehow, again, that when we adopt a premise, we're right, we must defend it, and that somehow somebody that holds a different view is then wrong, and then they become our enemy, and we can't have any common ground. And that again is going to I got to tell you, it's criminally insane, but it's going to work very well in keeping the power away from us, keeping us from having power against them, because they've shattered our ability to hold any material strength. Right. So Cami knows, right? Material sciences. If you can shatter the strength and get it to where you're in the wrong polarity, get those polarities lined up, you can shatter its strength.
But that's where this is important. So with people like Clarissa, in friendliness, because I really, in humbleness, don't understand in astronomy how you can base everything. First of all, Hubble came up with something called Hubble's Law. You can even pull up the Wiki's law up there called Hubble's Law, saying that things to go in with expanding the expanding universe theory. He declared redshift. They saw a shift of red in most of the stars,
right.
And people were in agreement that they saw a shift in red in most of the stars. And remember, we're looking at optics. There's a lot of things that can shift light. It's an absorption spectra, and that you can bend light with a crystal, you can bend light with a magnet, you can bend. I showed you how to do it magnetically. I've shown you how to do it with a crystal. You can do it through many waves. You can affect the wave, right? But they have it go. So their entire theory is based on that it is Doppler. You can get a redshift by Doppler by speed, but it's not the only reason that you can get redshift. It's just
through magnetism.
But moreover, that also implied that the universe was expanding, and then he took the position that was so horrifying that the implications were so terrifying. That would mean that we're at the center, because then everything is expanding outward, and so that's when he had come up with the bubble theory, that we're on the edge, we're on the tangent edge of a bubble, and the whole thing is expanding. So therefore, everything is expanding all at the same time. It's just nonsense.
Yeah,
they're all bad talk.
But we're missing the basic, Baldini. We're missing the basic that when Einstein came in with relativity, he put in the vacuum of space that got rid of wave theory. That's the only reason they have to have a dual particle, is it has to travel through the vacuum.
Yes.
But when he got rid of the wave theory, he got rid of Hubble's law. But they kept that because Hubble's law is wave theory. But if you make it change into a particle, how can you?
It's the same with Newtonian and Einsteinian physics, right? That they don't.
But it's a complete. You can't have Hubble's law and have it be a particle. So
no,
Clarissa,
you can't.
how can it change into a particle when it gets outside of our atmosphere into the vacuum of space? How can it turn into a particle and yet you read your science via wave?
Yeah, it's
fringe. How can it turn into how can you read it as Doppler when you're ignoring inverse square law, or the fact that, again, the sun gets that small in 8 light minutes. They're moving these things willy-nilly, 400 light years, 300 light years, 50 light years. It takes 8 minutes for the sun to supposedly go from ginormous, over ginormous, to what we see in the sky, according to their theory. So they're only reading Doppler and redshift and that on stars only in that one area, not in size. What they do, because you can't touch it, is every time they change it, they just make the things bigger and brighter.
Scaling, very
in terms.
Yep.
Yeah.
Exactly. And that's the sort of the thing here. And I would say, Rose, one of the things to be on the lookout for when you're having these conversations is when you come to a topic such as that. For example, when you get to something like, you've got a gas with no intermolecular covalent bonds in a vacuum of 10 to the minus 17 torr. So how in the world is it creating, not only staying together, but creating gravity? Right, that it's clearly a problem. If the opponent can't just immediately start, if they don't stop throwing ad hocs at you or ad homs, right? So either just something pulled out of their butt, some rectal extraction, or they're just going to start attacking you. You're just too dumb to understand it. If they start throwing that out immediately, and if they won't concede any point, like, oh, gee, that's, I don't know, I'll have to get back to you on that one. There's nowhere to go. Right. If they, and that's where I knew right away that your wino friend was not, they're not going to be anywhere to go, and they can't concede even the most basic points. Right. Then there's nowhere to go with that. The sky is blue. No, it's not. I thought green one time. Okay. All right. One time was green. And if they can't admit that one time it was green, right, then there's nowhere to go.
Yeah, I think that's the moment when I maybe kind of gave up on trying to defend my position more, when she would not concede that she made a mistake about what they say gravity is, especially reading it off of,
right,
the holy Google.
Sure.
So, yeah, I think it's just very, very, this like tribal thing where it's just like, or like label theory where like she is identifying with her beliefs. So
well,
she has
even they refer to it as an acceleration, but I didn't see anybody come up with that, because that's what we're claiming it is. It's an acceleration. The question is what is it that's causing that acceleration? Right. So we totally agree that, gravity may or may not be, whatever that acceleration is. Theoretically, according to physics, there would necessarily need to be a force creating that. But we don't know that for sure. But we do know that objects do accelerate as they're heading towards the ground. And that's the big question. What exactly is it that's causing that?
Yeah, I think it's observational, right? We can observe it. I don't have any claims on what what it is, but I can observe it, and to say otherwise, I think is problematic in the extreme. To simply say, well, then you're looking, well, if you look at it from a different angle, yeah, but nobody looks at it from that angle.
and they're declaring, well, it's mass attracting mass, or it's falling into a hole or bendy space time. It's like, come on, that's ridiculous.
You can't prove any of that. There's none of that's demonstrably
any more than I can prove that it is dielectric inertial acceleration. But at least we're operating from some science that's been around for a while. But I fully admit it every single time. I cannot prove that beyond any reasonable shadow of a doubt whatsoever. So, but like I said, that does not negate the observation that whatever is happening, it's causing acceleration.
Yeah. You have to you have to look at the things and acknowledge the observation. It is what it is. What causes it? Fuck, man, I don't know. I mean, we can hypothesize, we can speculate about it, we can rule some out, we can use a variety of abductive, inductive, and exclusive reasoning to get through what it might be. But until we can physically get our hands on it, it's going to be pretty tough.
What has happened too through here is again, they're saying that we're science bashers. We're not science bashers at all. There's a difference called, again, industry and reality physics that we engineer by, and theoretical physics. What I personally think happened is a lot of the theoretical physics got laid into line before our practical physics caught up with it. And right now our practical physics throw it out the window entirely, which again, they should at some point say that these things aren't accelerating away from us, and maybe we're reading this entirely wrong because our mismatch is off 10 to the 120th power, so we might have a problem. But call that the same as reading and saying what something physically is. Something I think that's really interesting that they don't tell you or they don't teach you. I know that she was saying that without their astronomy and that we wouldn't know when to predict eclipses or any of the stuff going on in the sky. And yet a man out there named Al-Biruni, an Aryan philosopher, yes, an Aryan or an Iranian philosopher from the way back, was doing an astrolabe, and he had the motions of the skies. He completed his little observations on where things were when the eclipses would happen, when all of these events, because remember, we're looking at observations that we see and we're trying to make the math fit into it. So they're now working that they can get the orbital mechanics of it, but it doesn't change. They're just trying to get the mechanics down to what they see in the sky. Are they getting it down the correct way? I don't know. She argued with you a parabola versus a sphere, but for the size that you're dealing with, your measurements are going to work
And
out
you know
the
what?
same.
You know
Yeah.
what she didn't do is she never did the equation, because if she would have actually carried out her math instead of just showing you the math, if she would have actually done it and then you would have examined it point by point
They would
to
have
the
matched
8
up.
inches per mile squared all the way up to 1,000 miles, they would have matched right up nuts on. And then you have to look at her and say, well, what's up with that, Carissa? You know?
Chris, so yeah, we understand it's a cheat. We understand it's a parabola. We understand what a parabola looks like. We know what parabolic dishes look like. But when you cut off the slice of it and it's giving you an easy math formula that simulates, yes, that's where you can look at things like redshift and that differently, that the formula would look the same out to the first 1,000 miles on what they're calling the size of our sphere. So you can use that. You can use their cheat math, which is much easier to do, and the math will come out the same. Are we saying we live on a parabola? No. Are we saying that the math will work out at 5,000 miles? No. But we're saying that it does. That little arch matches the same of it.
Yeah, I did. I think I said that, right?
You did. You said
okay.
it very well, and she wasn't grasping it. She just you could tell that was a trigger point talked into her, that these people are stupid. They think they live on a parabola. No, the parabola is like the Polaroid filters. It's a way to simulate. So that parabola, the math was an easier way to do it, but you will get to the same answer, and that's why it's effective. That's why it simulates it out to that fact. If you keep going, no, it won't.
I sent you the equation that she sent me, and she said, do keep in mind that this is not taking into account the height of the object, and it's just telling you where the geometric horizon is.
Right.
And so what I'd like to do in order to increase my comprehension of like math is myself figure out how to incorporate that. Thank you so much, Jason. Jason just brought me food.
Awesome.
The geometric horizon that nobody can see, and that now that the ballers flat out deny is there.
You wouldn't expect to see it.
But I mean, just hypothetically, then what I can do is I could plot on there. But well, actually, according to her equation, it was something like only a few miles to it. So I mean, it. Anyway.
She was wrong on almost every count. And
she was repeating back.
She was all she was doing was parroting, and half the stuff she was parroting, dead wrong. She was wrong about, Einstein. She was wrong about gravity. She was wrong about everything. Every 2 seconds I was correcting her in the chat. I mean, I just couldn't believe how anybody could get so many things wrong. But, she was doing it.
But they do it. Yeah, they do it all the time, and they're convinced of it, right? And they'll double down.
And in a condescending manner, she was doing it.
Yeah. That's why I don't play chess with pigeons. I just refuse to do it.
I didn't pick up on the condescending because my view was like feeling sorry for her.
You didn't pick up on and you guys do GLOBEBUSTERS physics? You didn't catch that?
She dropped that down
because
like
I don't
times.
consider that an insult. I screwed up, Bob.
Well, no, I mean, she definitely meant that as an insult, because, here I am telling her she's wrong. So therefore what I'm saying becomes GLOBEBUSTERS physics, and it obviously must be wrong, unbelievable.
Well, congratulations on having your own kind of physics.
Right. I know. And I do for another Nobel Prize now.
For which you won a Nobel Prize. Right. Exactly. So come on. Anyway, I have to wrap up here pretty quick. So if there's anything else we want to get to, then let's do that.
That's it. I guess after you go, I was just going to want to play this cool video and then have Cammie and Bob explain to me I like the way you guys explain to me what's happening.
Well, because they're awesome.
Yeah.
But yeah, my encouragement always is, don't. I love that you have the heart for it and you have the patience for it. But I wouldn't necessarily judge your ability to either understand or explain it well based on their ability to receive or accept it.
Thank you, Baldini.
Yeah, I love you, kiddo.
I love you too, and I don't know when we will be able to do the poppycock report, but it seems like we're going backwards because now I'm like stream, and you're taking a breaky poo. But we'll figure it out. And if I do if I do something without you, it'll be like a perpy kirk.
Yeah, but if I do cocky pop, but
cocky pop and perpy kirk.
We'll figure it out. It won't be long. I just need to get my ducks in a row, because it's coming that time. So
hell yeah.
All right, take care, kids.
Mwah. Bye, Baldini.
Mwah.
Love
Bye,
you.
Baldini. Thank you so much. Thank you.
Bye.
Bye-bye.
Goodbye. And I put Crow into the title, but then last minute he says that he's going to be tied up, which I don't mind because it just means that we're such good friends, because only a good friend would cancel on someone last minute like that, right? So, anyway, maybe he'll show up later. Shall we play this?
Certainly.
Alrighty then. So...
put a superconductor on a giant neodymium monster magnet. So in order to cool this down, we need some liquid nitrogen. So I have here a ceramic with the acronym YbCO. It has yttrium, barium, copper, and oxygen in it. Now this is a type 2 superconductor. And what that means is that it can actually undergo quantum locking. So now what's quantum locking, you ask? Well, let me show you. Okay, put our superconductor down. Let's bring our magnet near it. Here we go. Whoa, picks it right up. Whoa, no way. Look at that. It's like there's a string connected to it. Holy cow, that is so cool. It just holds it in place like that. That is amazing.
Okay, Bob and Cammy, I don't understand why this is happening. I don't understand what a superconductor is, what that liquid was, why this is happening with this trigger, Carissa. I don't even know. And also, the reason I bring this up, Cammy, is because I showed you that really cool artwork, which I don't have handy. Oh, wait, maybe I will in a second if I can text it to myself, of the Freemasonic artwork that's demonstrating what I think would be the source sun. And in the little corner, didn't you say that that's what you thought that was? And now as I'm looking at it, it does look like it.
Bob, do you want to do the quantum locking, or do I want to do it? I know what the quantum locking.
Okay, I can talk a little bit about it. First of all, the liquid that he's using, I believe, is probably liquid nitrogen. He may have said that. I don't know if he did or not. But you have to actually cool these superconductor materials down to near absolute zero before they start taking on this effect. Okay, so then what happens is it causes the magnetic field. It causes a change in the magnetic field to basically where, parts of the magnetic field penetrate the object, and then it becomes trapped within the magnetic lines of force. Okay, and it's based on something that's called the Meissner effect, and it's been a while since I've actually looked at this, but it loses its flow to electrical currents, and when it gets down below a certain temperature, and it causes this quantum locking effect. Now, honestly, beyond that, it's still kind of a mystery to me, but we can see that it's happening, and it's a very interesting phenomenon.
Okay, and I'm going to take it a little bit further. When you, a lot of solids, and we hit this in gemology a lot, and you hit it a lot, especially with fluorescents and magnets, temperature is very, very coefficient with how they work, either on the magnet itself or on the object that you're having the effect on. When you take something that's a superconductor, superconductors have their lattice structure very columnated. So when you take this vibrating columnated structure on this and you get it very cold, what you're doing is you're slowing down the movement of it, and it can lock into position. And that is the quantum locking, is the lack of movement on it is almost working like a string between the two, because the two are acting off of each other differently. The temperature has that effect. With magnets, for instance, if you supercool them, they also have a lot of optical effects, like circling the field and different things. It's an interaction with the temperature, and temperature, same with fluorescence, it makes fluorescent lighting a lot colder. It slows down what they would call the electrons or the things in it. And when they're slowed down and not vibrating as much, you have a more static field.
Cool.
Mind blowing.
Yeah, it really is. That's one of those crazy phenomenons, and we've seen videos, interestingly enough, where, in fact, Iru presented it at, I think it was the Denver conference, that one of the Go Fast rockets, or maybe it was the Go Fast rockets, as it went up higher and higher and higher, it was weird because its temperature that it was reading was actually getting really close to absolute zero. And of course, that's when you get into that area where these gases essentially start to become more and more dense and then ultimately turn into liquids, which is pretty crazy stuff that's going on. So this is not normal physics that goes on down here on good old plain Earth.
Right, and the physics from going to liquid in your gases, they'll also go in or crystallize into solids. Again, it's happening everywhere all around you. All we have to do is look at it not through computer eyes, but look at it through our eyes, our optics, and again, polarized in different, tools that filter it out and clean up what we're looking at, logical tools.
Wow. Are you looking at my screen right now? Do you see the picture I finally got up?
I do. I'm trying to make it big enough for me really to see. Let's
see if I can do better.
What you have is a Masonic tracing board, and I'm drawing it to scale. You need your two pillars, your sun and moon.
Okay, so yeah, I really liked this because I found this in 2018, right around the time that we put out the first episode on the double sun.
Mm-hmm.
And so I like how it just shows, it almost looks like you could call, it doesn't really look like a firmament, but I like the idea of it like shining through something there. But what isn't included in here is the idea of another moon, because how we were talking about the possibility that if there's a source that's powering the sun, then maybe there's a source powering the moon. And Crow has talked about how with his telescope work, sometimes he'd be looking at the moon and then at a different part of the sky there would be a lighter area. Have you thought about those ideas?
I have thought about those ideas a lot because the lunar wave is interesting. What it looks like optically, and this, from my attention in talking, what it looks like optically is it looks like an optical jump from a double refractive solid, which is very common. Again, a lot of your solids have one single optic axis, some have two. Most of these things that they're putting the math to are optical effects that you're just writing out in math, reflecting what the difference is. So if something has two optic axes and you change the polarized light that you look through it, the image will shift, it will move, and the amount that it moves is something that we measure. Now, that's what when you look at a lunar wave, that's really what it looks like, is it looks like that line jumping or things jumping, like when I was showing you at my house, and we're using calcite as our double refractive material instead of the moon. We were, again, trying to emulate or simulate it. And so I can simulate a visual lunar wave with polarity, but in other words, it's acting like a material that's double refractive going through a change of polarity. It looks like the sun's reaction to the Polaroid fields was it being a source, not reacting to, but it actually being a source of polarized light. And if it's creating a polarized field, then the moon would be a separate object going through it, again, in the firmament, the one that we wouldn't see. And as we're getting it, mirroring it down, which you've seen with my, the domes and the work that I've done in the miroscope, Rose, how easy it is to get properties to not only optical properties, but thermal properties.
Yeah, you like the cold, like if you put an ice in the miroscope, the hologram itself is cold. And very cold, not just like a little bit, but you can definitely sense it. And we did a stream, if you scroll way into the beginning of my channel, we did a stream about how the moon could be a hologram, because I didn't even realize that there were such things as natural holograms. I thought it like required digital technology. So thank you for saving me from that misconception. And then also we talked about another possibility of the moon being kind of like a crystal growing on the firmament. And this here I have on the screen is the heliospheric current sheet that you were talking about. And as I described in the debate, we see the solar system overlaid these petals, and the sun would be in the center. But really what you're suggesting is that the sun is actually the source. The real sun is the sun that we can't see, is the thing that's creating this field, and then the lunar wave is the moon. I wish you could see my here's my my finger here, this finger, fake finger. The moon would be like going like this through
the petals.
This is a wave and this is a wave. So as the moon is moving, it's interacting, its field is has a birefringent properties that allow it to interact in this way and be double fractive.
By Jove, I believe she's got it.
She's got it. She has got it. Now, what I've
nice.
Now, I was predicting that on the lunar wave before what you guys saw with the solar. Not predicting, but hypothecating it as a possibility because it matched the optics so well. But when I took a Polaroid filter and looked at the moon directly, I could not push the effect, which I should be able to do. So that's telling me that the moon is the image of the moon, not the actual source of the moon, if it's causing the effect. So yeah, I've been looking for the source moon, and you guys found the source sun instead. But it all, again, the sun would be like a polarized light source, and the moon, the lunar wave, is really acting like a natural crystal going through polarized light, how you would optically see it if you scaled it down. Again, these things are not, I'm not doing theoretical physics at all. I'm doing things that I can scale down and reproduce because they happen in reality. You really do switch optic axes, just the way, like I'll show you with like redshift we talked about a little bit. Things that happen commonly, let's see if I can drop a video for you to play, Rose.
Okay, good. Do that.
Where's the easiest place for me to drop it? It's a video I made.
Oh, just put it in the private chat here.
Okay. Bob, if I have it up on my screen, how do I move it to the...
Or if you want, you can click share screen.
Just copy the address. Just copy the address up at the top.
There's no address. I made the video.
Oh, it's a file on your computer.
Right.
You probably should just share your screen with it.
If you click share, you can choose video file.
Okay. Let me just try this. I apologize, everybody, for my non-tech savvy. Share screen. And I'm going to pick this screen here. And share. Do you have it up?
No.
Dun, dun, dun.
Nope. Let me try it again. Maybe I don't need to share it with share screen, screen 2, share.
Oh, wait. What if you click share?
How about now? How
that
about now?
Good. All
okay.
right.
Well, let me share with audio. Okay. What I'm going to do is just play this for you, and you'll see when I take it away. I've got all clear items. I'm using my computer screen as a polarized filter. I'm using that filter in front of me as a polarized filter. And what's in between it is just a sheet of glass, which glass would be, by the way, isotropic, the same in both directions. It's not going to react color-wise to a Polaroid filter.
As opposed to anisotropic.
As opposed to anisotropic, which the cellophane tape, like I said, a lot of gems are, natural solids are, your cells in your body are. This carries to not just gems, it carries to everything in life on how. So watch what happens when you put it between and how it breaks up the light. And again, everything in this picture, in this video, is going to be colorless.
Okay.
And we'll show you afterwards.
But we're seeing colors because of the filters.
Yep. So when it goes to red, you're going to get a red shift. I mean, that's red shift. That's just shifting a light. It's an optical shift. Do you see how all of that is see-through? So it's saying that colorless, you can bring out the lights just by holding a filter, and what angle of light you look at it through, you can isolate the light wave. And so redshift is an angle of a stretching out of a light, even, or a fringe. Again, it's just stretching the light. There's no color in these. We'll play it again. Yeah. Nothing has color.
And when it's anisotropic, is that the situation where all the colors of the rainbow become segregated and like fragmented out like a rainbow through the thing?
Yep, and that's what you're watching here. Is you're watching, and this is done with, you can see on there, this is not fancy. This is packing tape. Other things that do this even prettier is next time I'll do it with like sugar. Sugar is anisotropic. Salt is isotropic. You'll get salt when you do this to it will just stay gray. Same with the diamond. If you did this with a diamond, it would stay colorless like this glass. But if you do it with something that's anisotropic, which is again a quality of in nature that happens all the time in plants, in animals, and in rocks across the border. They don't teach you this. They should.
Is mica anisotropic or?
Yes, it is. Mica is very anisotropic. I was doing this with mica. So there you are again. I'm showing, and I can do this with mica too. Here's your colors breaking out one at a time as I'm changing the filter.
Now, what could you do something with that filter to bring out different colors? Like if you were spinning it slower, or if you added a temperature to it, could we get whatever color we wanted?
We could add temperature as a coefficient and change out the way it would react to it slightly. We could definitely change the angle that I'm holding see how I'm holding that at 90 degrees up against the computer screen? If I changed the angle that I held it at, I would change the way that you saw the light. What a lot of equipment that was on my desk for over 30 years on was just 2 Polaroid filters that you looked at everything between it, that had a light box underneath it diffused, much like your computer screen would be. Expensive piece of equipment, and all it was 2 Polaroid filters, because it is such a non-destructive physics way to test solids without causing any destruction whatsoever, because different matter and different solids handle light differently, have different properties to what they do to the light. So it is a non-destructive test that, again, you can hold it in your hand and replicate in that. So this is anisotropic. These words that we're making hard and are being scared of, they'll write it down as a mathematical formula and at what angle you're holding it at and all of this. They can repeat this over and over again. Different materials have different angles, and they're data points. They're nothing but data points that you could collect and identify the materia by the data point. Al-Biruni, that same person that mapped our skies, was the first gemologist. He was the first person to look at stones and look at rocks and categorize them by their properties other than what color they were. Before Al-Biruni, all red stones were rubies, all white stones. In other words, it was only what color it was. Al-Biruni noticed that when you took some red stones, you crushed them, they were red. You crushed other red stones, you crushed them, they were gray. You crushed other ones, they were white, the powder. It's called a streak test even on it. He noticed that the colors were made different ways. And so he came up with different ways to look at rocks and stones and say that their density had something to do with it. The way they handled light had something to do with it. All of these things that were properties of the stone were ways to separate them, and not just what color they were. Like, oh, it had redshift. It was more than, is there redshift? Hematite. For people that know what hematite looks like, it looks like a BB, a gray BB. Have you ever thought of the name hematite when you look at it? Because it looks metallic, Rose. You know what hematite is?
No,
pull up a picture of hematite on your screen.
All right, I'm doing that. Oh, I like hematite.
Okay, so Rose, bring hematite up for everybody.
I know, I'm going to. Here we go. I like hematite.
So hematite, people. This stone, hema, red.
Yeah, like blood. I thought of blood as soon as I heard hema. Yeah.
So this stone, if you crush this stone up and make powder under, or if you take this stone and you run it on a white ceramic plate, it will make a blood red streak. Type in streak test hematite. It's one of the properties of hematite is it crushes red, even though it doesn't look red.
Question here, Cammie. Mm-hmm. Now the source sun looks much more red than the apparent sun. Mm-hmm. So what does that tell us about it?
We have to think, it talks about, you can get into the absorption spectra and all kinds of physics. The other thing about this in the optics is I'm nothing special out there. I'm talking because I did the optics every day in and out for over 30 years. So I have practical working knowledge, but I don't have a university degree in other words, we did it for very real, practical, physical practical
That's more
purposes.
impressive, though. Like you said, with the let's point out why that's so important about the Gem Society thing is that we know that they can't lie because they have to put legal documents to it. So you should be paying attention to the people who have like the legal concern where they're dealing with money and people identifying gems for an industry versus the poppycock associated with education, which is actually government who lies.
So yeah, in industry they have it down pretty down pat because, like as you can imagine, in the jewelry industry, there's a lot of fakes, and people go out of their way to try to fake you out, and grow different synthetics, and there's always something new out there. It's not only do you have to identify what you're looking at, but you have to identify what you're looking at, knowing that people are intentionally trying to trick you. So you have to really get an eye for what's real or what's not. Now, these same optical properties, I know, go to the medical field and go to any type of optical field, because again, the math is nothing more than a scary educational system to scare people away, I think, from what's really happening. How hard was that to look at you to understand what anisotropic was? It breaks it into the spectrum. The glass behind it did not break it up into the spectrum. It was isotropic. That's, again, between two polarized filters. I'm probably talking too much, but again, it's practical knowledge versus theoretical knowledge. And practical knowledge, when they come up with a new way to deceive us, we add it to our list for things to check for. And they're always, coming up with new ways to trick.
Yep.
But yeah, properties have meanings, and redshift, again, is a property, but it's not a property that you necessarily say, oh, it's Doppler. That's kind of a leap. That's a theoretical leap of faith that Hubble made, and they based the whole expanding universe around.
It's all abstract, and it cannot be demonstrated.
You can't touch the stars. You can't touch it. You can't. I can scale the same effect with Doppler, or I can scale the same effect with a gem. If the diamonds, let's say, twinkle, twinkle, little star, how I wonder what you are, and you really were a diamond in the sky, guess what? You might get some redshift from that. You're changing the material in the sky. It could be a diamond as well as it could be a light flying away at unfathomable speeds, never looking any further, never changing position year after year. I'm just saying that I don't know if I'm stupid for thinking that's a possibility, that it could be some of these other things that we know cause the effect, that we
Definitely
know physically
not stupid,
cause it.
Cammie. Wondering if things could be possible is the least stupid thing that one can do. It is always good to try and wonder and use our imaginations to consider what it is that we don't already know. And so I wanted to keep this close to an hour because I want this to be like a very shareable video for anyone that saw my debate and wants to hear like the main points that I didn't get into and these specific topics. So I want to close out with this, Cammie and Bob. I know you guys are getting a P1000 soon, and there are more experiments that we want to do. Chris and Crow are going to do more shooting on the same day at the same time, I think. And I know that you wanted to introduce that third filter while the source sun is being captured. So tell me a little bit about your hopes for the future in these experiments. What is it that you're possibly expecting? And anything else you want to close out with for anyone who watched my debate?
Okay, what I'm thinking of is I'm thinking of practical measures that people can go out and look for this without spending thousands of dollars in equipment. So I'm looking at a simplified way to look at it. So for instance, we know that if we caught that and we caught your spirit sun and you could turn the filter at just the right area and look at it and get it to go out. Your other thing that you should be able to do with like a full spectrum camera is where it's, if you crossed your two Polaroid filters and had a completely dark field, that same light source would start introducing more light into it. So maybe if we could get a whole bunch of people looking up with full spectrum cameras, and then again, maybe I can start working on with the red. We need the red was predominant, so we could maybe work with absorption filters and that. I'm working on isolating it down. I am getting a camera myself. I looked at the delivery notice. It got moved from yesterday to Monday. This was a really neat gift for me, because again, it does full spectrum, and it does have a lot of different filters in that. I'm not a photographer. I have no photography background whatsoever. What I have learned, what I have had on my desk all of these years, though, are filters that I've just used in a working possibility. And guess what? The filters are the same filters on the camera. I was just, instead of to get the prettiest picture out of these filters, I was taught to acquire data out of these filters using them. I was just, taught to look at them and write down the data points, like see what I observe and mark down what the data point is. What angle is it bending, or what am I looking at? I'm going to be looking at the full spectrum camera and using the filters like I've been using filters on my desk, and just trying to look at it new and see. I don't know if I'll be any good at taking the shots or doing things out of it. It's a new experience for me. But I do think, again, according to wave theory, adding it in, the reason that they haven't really seen it when they're looking up at the skies is I think that they've taken the filters that would show it completely out of the mix, especially when looking at the night sky, by probably telling you that, oh, all the polarizing filter does is remove half of the light. You don't want to do that. And no, it's not that it removes half of the light. It's that it lineates the light, and you only get the light in from one direction. And that's very, very different than having it tinted and removing half the light. It's a complete different concept.
I forgot that I was muted. It's so true that there's all these big words that people are afraid of, when really just like a polarized filter, it's just those little tiny lines creating those blinds. And if we could just show people things by their visuals, I think it's going to be a lot more easy for people to understand.
Exactly. And it is all just visual effects. So how right is it to do that? How correct is it to show you that, oh, by the way, you're looking at a visual effect. This is really what it is. It's not these numbers on a page. The numbers, we're trying to get to describe it the best we can. But it really happens in reality.
The videos that you texted me showing the domes next to that big globe that you had on that stand, and you were showing me how the domes automatically by themselves generated like a perfect hologram of that globe within it, and it looks like you could just touch it. It's exactly it looks totally physical, just like the Miroscope does.
Would you like me to find that?
Yeah, let's show that, and then we'll end the stream.
All right. Bob, do you have anything else to add while I'm looking for the video?
No, not really. I think you pretty much said it all. And, we may touch on it a little bit more tomorrow. I just want to remind everybody that tomorrow's Globebusters will be hosted on Rockfin. And so if you haven't yet, you might want to sign up over there and, come and check us out on our first episode there. At rockfin.com, and I'll paste it in the chat here for everybody, where you can go to sign up if you want to. But other than that, I think Cami pretty much got it covered tonight.
Yeah, I think. Thank you so much for bringing up Rockfin. I am so tired of YouTube. I really don't like using it, and I see this platform as a good way to try and get lots of people somewhere else that doesn't hate us. You know what I mean? Like we want to put our energy towards those places. And so that's why I filled out an application for Rockfin, because I want to be part of that encouragement. And so I would love if they pick me to be part of it. I will try to only put exclusive content of mine on there only, just to try to be part of the encouragement of getting this community somewhere else other than YouTube. But who knows if it will work.
Yeah, no censorship there. That's the great thing about it.
Yeah.
I'm so tired of YouTube. Just
it doesn't feel good to be giving them our valued, energy. Cami, do you have the video up?
I have the video up. No, I just lost the StreamYard on how to share my screen. Crap. Oh crap.
You can't see you don't see the share button at the bottom under my face?
I don't see your face anymore. Hold on.
Let me see if I can help her.
Okay. Right on. Let me say hi to the chat. What's up, Karen? How's it going? It's so good to see you. Did you like how during Modern Day Debate, I was like, oh, Karen's too good for this channel. I was like, I don't know if Karen's going to show up here. She's a high-level bitch. Don't you agree with me, kind of? It's just, Karen,
Totally.
I love you so much.
Karen is the bomb. She was at my house today. She was setting up Bob's studio lighting.
Studio lighting. Yep.
That was nice.
And
Yeah,
we
I
had a
can't
great.
believe they came over to do that. Her and Brian came over to do that because, you know, my stomach was killing me today.
Oh, no.
And so yeah, they came over just to do that just for me. And I'm just like, wow, that's so cool. I have such great friends.
Yeah. We are the best. Oh, Cammie, I'm going to put your... people are asking where they can find more of you. So your channel is Aisling717. So I'm going to put a link in the chat there.
And they can also find me sometimes on Iron Realm Media on Friday nights.
That's right. Iron Realm Media channel. So let's put... Here's Cammie's
And it's
channel.
podcasts right now because they're operating on strike. So we're on a backup for 2 more weeks.
Oh, okay. I'm going to put that one in here first, and then people can search for the other one.
Rockfin,
Right.
it's like perfect for you to come over. Definitely put in an application and stuff for Rockfin Rose. Your channels that are exactly what. Again, if we can all get over there, then it makes such a beautiful where we can all work together. Yet not, we introduce it through other parts of the community, other Scott Adams, different channels that wouldn't necessarily now. We know YouTube won't refer to us, and I think that's so important to interact with other channels. I have that video ready to play when you're ready.
Perfect. Got it.
Got it? Okay, what's going on is this is just my desk. And I'm holding it's at nighttime on my desk, and I'm holding a pen light, and I'm making this ball that I'll show you afterwards when we're off for us. I'll show you all of these pieces when we're done with it to show you the size. But it's my messy desk, and I noticed this was an accidental experiment. We make this happen all the time with parabolic dishes. But if you watch this, here's me doing that. And you'll notice that there's little domes on my desk. It propagated into, I'm sorry, I've got the background noise going on it. I don't know how to mute it. But you'll notice it's propagating into these little domes and completely all by itself. And again, you'll see that it'll even do both of them and reverse the order on them. There's another globe next to it that is actually reversing the order and making them 3D all by itself.
So freaking cool. And the daytime one looks cool too.
We'll do a daytime too on it here because this is showing you the pieces.
Yeah, this is, yeah. See how you're seeing it, the globe within the dome there, people? It just goes to show that just things aren't always exactly what they look like. It's like Plato's cave. What if the Plato's cave is really about the source sun?
It could very well be.
Something. And Plato's always talking about how it's all about remembering, and we already know everything we need to know. And it's just about remembering.
So yeah, it is about remembering. I think we do know, but if you look at this, look at the different angles you're seeing it at. Getting top on, they disappear, come out, but look at how these things propagate all by themselves in 3D.
Yeah, that is so cool. I love it.
Yep. And the second sun, by the way, is well covered in Vedic astronomy.
Yeah.
So this is something, the second sun, and like I said, it's not really a second sun, it's a source sun versus the apparent sun. But this has been something that's been known since days of antiquity. And of course they have to bury it and deny it because, in and of itself, it devastates the heliocentric model.
All right, guys, I want to end it, but first I want you to click on the picture of my dad and grandpa you have on my screen because I just see it and because I texted you that picture. So now I want to show everyone my dad and my grandpa. I was trying to show Cammie how my grandpa has eyebrows that look like caterpillars.
Well, oh man, where did it go? I just closed them on him. Oh crap! Oh, here they are.
It's okay. They saw it. It's all good. Anyway,
but yeah, certainly. Yeah.
I want to grow out my eyebrows like my grandpa one day. Maybe I'll be able to.
Oh, God.
You don't think that's a good idea, Bob? Wow, I'm surprised.
No, not for a girl. No.
Okay.
I'm sure Jason's with me 100% on that, too.
Oh, my gosh. He's definitely with you. He doesn't make that... He makes it perfectly clear. So anyway, everybody, Thank you so much. I hope everyone has a wonderful night. This has been so much fun. And since I just feel like listening to ODD Twilight Zone, I'm just going to play that as the end of the stream. Thank you, Bob. Thank you, Cammie. And cheers.
Cheers. See ya.
Peace out, everybody. Thanks, Rose, for being so fun.
Twilight Zone. We're living in the Twilight Zone. We're living in the Twilight Zone. These crazy days that we live in just cause me aches and pains. Lately my life is like a season of Stranger Things. This place is flooded with demons and they invade your brains. This is an artificial hell and they create the flames. Day to day I just try to stay strong and make it through. Wake people up from their slumber, that's what I came to do. Please don't believe what you see on TV and think it's true. It's all just targeted programming and it's aimed at you. It's everywhere, you're getting lied to and yet you barely care. People with common sense are now very rare. But the way that they brainwash you isn't very fair. They can shove that mind control programming up their derriere. I do not consent to the way they tailor society. Ain't no variety. Plus I really hate when they lie to me. I use music as a tool to release the anger inside of me. You don't know how fucking crazy it's driving me. That we're living in the Twilight Zone. They claim you have freedom but they don't honor it. The world is a prison and you're the occupant. We're living in the Twilight Zone. The government's useless and they're incompetent. And satanic pedophiles are prominent. We're living in the Twilight Zone. The things that you believe are the total opposite. And being called crazy is just a compliment. We're living in the Twilight Zone. It's ran by the New World Order conglomerate. But there's a storm coming and there's no stopping it. We're living in the Twilight Zone. I ask myself, why do I even bother? Cause people are just like sheep that are lining up for the slaughter. If they're killing rats with fluoride, then why is it in the water? They're using the news to fool us, divide us so they can conquer. The longer you stay asleep, then the longer I'm gonna scream at you. I can't believe you let them deceive you, it's inconceivable. I won't stop until you wake up and do what you need to do. This world is overran with an evil that is unspeakable. Most people don't know, so they just vote and pay taxes. The devil's hiding in the shadows and controlling their actions. And they think that the earth is a spinning globe on its axis. But I don't have any time to devote to this madness. I have nobody to relate to, so I ride alone. Just me and all these wild thoughts that are inside my dome. I feel like I don't belong here and I can't find my home. I'm tripping and I'm wishing it was different, but we're living in the Twilight Zone. They claim you have freedom, but they don't honor it. The world is a prison and you're the occupant. We're living in the Twilight Zone. The government's useless and they're incompetent. And satanic pedophiles are prominent. We're living in the Twilight Zone. The things that you believe are the total opposite. And being called crazy is just a compliment. We're living in the Twilight Zone. It's ran by the New World Order conglomerate. But there's a storm coming and there's no stopping it. We're living in the Twilight Zone. Twilight Zone. Twilight Zone. Twilight Zone. Twilight Zone. We're living in the Twilight Zone. Twilight Zone. Twilight Zone. We're living in